scalars, okay, time and length and mass, and we can take work, okay. And what about your distance, area, volume? Yes, any other example? Temperature is one of the example, and like you can money, voltage. Any other example for this? Yes,
So degree, angle,
students.
sir, angle measurement degree.
Yeah, degrees. Degrees, like, okay. And these are the example for scalar. Here coming to the vector. So what are the examples for vectors here? So coming to the vectors, that already we've seen, that displacement and velocity, acceleration, acceleration. Then I think weight also example, and some momentum.
Force.
Yeah, force. Any other example? Okay, these are the etc. So these are the examples, a few examples for vectors. These are the examples for scalar. Okay, right. Coming to yesterday, we discussed about the position vector. Okay, every vector having an initial point and a terminal point. Okay, I'm taking this is the initial point, like starting point, B is ending point in the direction A to B. The vector can be written as AB vector. Vector AB. This the symbol is arrow symbol. Arrow will represent the direction from where to where, A to B is the direction. This is also can be represent as A vector, small a vector, B vector, C vector, like that we can take. So A is called initial point, B is a terminal point, whose magnitude is given by modulus AB vector, modulus vector AB, right? And this is also can be written as simply AB, the point A to B, AB. And this is also can be written as magnitude of A vector, or this is also simply can be given by A. This is nothing but magnitude. Magnitude of given vector can be represented as modulus of AB, or simply AB, or modulus of A vector, and this A is given by like this. So if I take the top point A as x1, y1, z1, B as x2, comma y2, comma z2, right? Then the vector AB is given by x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap, right? So this is about the vector AB. So this will give the vector AB. Then here, simply observe students, here x2 minus x1 and y2 minus scalar components. This is very important, scalar component. There are two types of components are there, scalar components and vector components. Coming to here, the scalar components are x2 minus x1.
Sir, in the we have modulus AB, that's the vector form, and just AB is the scalar form.
A modulus AB vector means it will give a value, real number. Here, this also can be represented as AB, simply AB. Like AB formula means we know that when they given 2 points, the distance between 2 points is simply x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. Distance formula. Okay, the distance between A to B is given by its magnitude. Okay, magnitude always positive. The length cannot be negative. Okay, this is always positive real number. Okay, Like for example, here these are the scalar components z2 minus z1. And coming to vector components, like if I take any vector, a vector A is equal to a1 I cap plus b1 j cap plus c1 k cap. Nothing but here the scalar components of this scalar components are given by a1 b1 c1. Coming to the vector components, next coming to the point vector components, some questions are there based on scalar component vector component. Coming to this, here x2 minus x1 into I, the vector component means along with I cap, like x2 minus x1 into I cap, comma y2 minus y1 into j cap, and z2 minus z1 into k cap. So these are the vector components along with vector unit vectors. Here I, j, k are the unit vectors along the x-axis, along y-axis, along z-axis. Right. Coming to this example, here what are the like vector components here? Simple a1 I, comma b1 j cap, comma c1 k cap. These are the vector components along with unit vectors. Okay, first there are two types of quantities. The quantity which involves on only magnitude, those quantities are called scalars. The quantities which involves magnitude as well as direction, those quantities are called vectors. Okay, like to take the any vector, it required one starting point, one ending point. Starting point is called initial point, ending point is called terminal point. Starting point is initial point and this ending point is called a terminal point. Okay, terminal point. From the distance from A to B is given by magnitude of the given vector, right? Here there are two types of components, scalar components and vector components. The coefficient of I, j, k are the scalar component, whereas including the unit vectors like a1i, b1j, c1k are called vector components, right? Next, coming to a unit vector. How can you find the unit vector? Very important. Okay. Fine. Unit vectors. If they give any vector, then how can you find its unit vector? Unit vector. For example, A be the given vector like a1 I cap plus b1 j cap. Otherwise, simply you can take the position vector of the point P. Yesterday we discussed that the position vector means take x-axis, y-axis and z-axis. Okay, takes x and y and z-axis. Fine. So this is x, y and z-axis, right? X, Y, Z. In three-dimensional x, y, z. Along x-axis, I am going to take the unit vector that is one unit distance, that is I cap in this direction, and here along y-axis I am taking same one unit length. This is j cap and this is k cap. Nothing but if I take the point here, let us consider this point is clearly like capital A, this is capital B, this point at C, capital C, this is clearly origin 0, 0, 0, and the point A is given by, the point is A is given by 1, 0, 0, but unit distance here 0, 1, 0, right? This is clearly 0, 0, 1. Okay, so when I take the point on xy plane, this is xy plane. Okay, yes or no, student? This is called xy plane. This plane is involving an x-axis and y-axis, and this plane is yz plane, and this is xz plane. If we take any point on xy plane, like I'm taking this point is like in xy plane, uh, this point I'm going to take as like a Q, and in YZ plane I'm taking R, in XZ plane I'm taking as S. So what about the point like Q in XY plane? In XY plane, clearly the Z value is 0, so it can be written as XY 0. In YZ plane, X value is 0. On YZ plane, if you take any YZ plane on that, X value should be 0, so 0 YZ. This is 0 comma y comma z is any point on yz plane. And coming to your xz plane, if I take s is any point, that is x comma 0 comma y. But if I take, this is on the plane, xy plane and yz plane and zx plane. So how can we write that the position vector? If I draw the, like if I take the initial point as O, and this OQ vector. How can you write the OQ vector? OQ vector is clearly given by xi plus yj, sorry, plus 0 k, here 0 into k bar. This is any vector in xy plane coming to the uh, yz plane. So what is the point on yz plane? On yz plane, if I consider position vector of the point R with respect to the origin can be written as here OR vector is equal to clearly 0 into I, y into j plus z into k. This is the position vector of the point R. In the same way, the position vector of the point, yes, position vector of the point S is given by simply OS vector is equal to O, nothing but starting point is origin, ending point is S. So xi plus, sorry, this is zk. So these are the vectors on xy plane, yz plane and zx plane. But if I take any point in the space, three-dimensional space, it should be not lies on the xy and yz and zx. If I take any point in the space, like P be any point in the space, okay, in two-dimensional plane, we may not be take the point here, like this is P of x comma y comma z. P of x comma y comma z is any point on the space, okay, which is not lies on the xy and yz and zx plane. It should be not lies on the x-axis, y-axis, z-axis. Then how can you take the point like position vector? Position vector is very simple. Like the position vector of the point P is, can be written as like OP. So this is xi plus yj plus zk. Very important, students. Position vector of the point P can be written as like this, and this is also can be represented as R vector. This will play very important role, okay, in entire vector algebra. Position vector of the point, that is position vector always can be taken as R vector is equal to xi yj zk. Then what is the magnitude? If you can take any vector, so magnitude of the given vector is square root of I coefficient, that is x square plus y square plus z square. This will give the magnitude, okay. So right, so here clearly when you next concept is a unit vector. This unit vector also can play very important role while discussing the OBT part as well as NCERT also. So unit vector, I'm going to find the unit vector of any vector. Like I'm taking here like R be the position vector. R be the position vector xi plus yj plus zk. Right, student? Xi, yj and zk be any position vector of the point x comma y comma z. I want to find here the unit vector of the given vector R. The unit vector of the given vector can be represented by r cap. R cap. So r cap is equal to vector r by magnitude of the given vector. That's it. Otherwise, AB is any vector, AB any vector. The position, sorry, unit vector of the AB can be written as like cap. So this is equal to vector AB by its magnitude, AB magnitude. Okay, V mirror. For example, I want to find the unit vector of the vector A. It can be represented, unit vector can be represented as A cap. It is clearly equal to A vector by its magnitude. A vector by its magnitude. Okay, mostly they'll give a vector and they ask him to find the unit vector. Unit vector. See here, the unit vector means first you have to find the magnitude of r. Magnitude of r is given by, since we know that root over like x square plus y square plus z square. Got it? This is the magnitude. Then here r cap is equal to like r vector, that is xi plus yj plus zk by this root over x square plus y square plus z square, or else this is simply can be written as x by magnitude of r into I cap plus y by magnitude of r into j cap plus z by, okay, z by r magnitude of r into k cap. I have written separately. So r magnitude of r nothing but root over x square plus y square plus z square. Okay, I'll give some example for this, and some in even section C students. Yeah, just a moment. Section C student will discuss the first exercise next class. So, second exercise is compute the magnitude. Okay, fine. Now I want to find the unit vector. For example, question number 7. Question number 7, find unit vector in the direction of, in which direction? So a vector, a already given, I plus j plus 2k. I'm going to do the sixth question directly. The question is given vector is like I cap, I plus j plus 2k cap. Note it down. See, all the questions are very easy. Only other than that last exercise, only few questions are might be lengthy or quite logical, but these are all very easy based on the formula. If you understood properly this vector concept, three-dimensional is very easy. No doubt in that. Okay, this is. In the sense, here, for example, let us take this is any vector. This is the given vector A. This is the given vector. Okay, but I want to know the unit vector along this vector I'm taking here. Up to here, it is 1 unit distance. It's mapped up to here 1 unit. I want to find this vector from initial point, this A to be the given vector, but AC be the unit vector. From A to C is the unit vector. This A to C I need to find. This A to C can be denoted by A cap. A cap is a unit vector along the direction of A vector. A vector direction like A to B, but unit vector I am consider like from A to C. This AC vector will give a unit vector of A vector. Sorry, AC vector. AB be the given vector. Along AB, I want to find the unit vector I am taking as AC. AC is equal to A cap. Fine. It is not at all difficult. First, you have to find magnitude. Magnitude of A vector. I told you very clearly, magnitude nothing but square root of I cap coefficient ijk vector coefficient 1 square, j coefficient is 1 square, but k coefficient is 2 square. So these are the magnitude of, this will give the magnitude, that is 1 plus 1 plus 4. So magnitude of a cap is equal to root 6. Therefore, since therefore we know that like the unit vector the unit vector in the direction of given vector, in the direction of given vector, that is given vector is a vector, is a cap is equal to vector a by its magnitude of a. See students, I have written that the statement like so definition, like the unit vector always, for example, in this question they are asking the unit vector in the direction of given vector. In this direction we need to find. Here a cap is equal to simply the formula is vector a by its magnitude. That's it. So already we found that magnitude, so that a cap. What about here? A cap is equal to vector a by its magnitude. Now substitute both the values. So since we know that vector a is, what is vector a? Amma? Vector a is I plus j plus 2k. Like you may write I cap, j cap, k cap, or else simply I vector, j vector, k vector. Because since everyone should remember that I cap is equal to I vector, j cap is equal to j vector. Sorry, j cap is equal to j vector, and the k cap is equal to k vector, vector k. Why? Okay, the unit vector of the I vector is should be same. So for example, I cap. What is I cap? I cap is clearly equal to, as for the formula, like I vector by its magnitude of I. Okay, I vector by, what is the magnitude of vector I? Magnitude always 1. Nothing but we get I. So I cap is equal to always I vector, j cap is equal to always j vector, k cap is equal to always j cap. So that any vector either you can represent I vector, I plus j plus k vector, or else simply you can write I cap plus j cap plus 2k cap. Both will be all are same only. Okay, right. Now here this is by magnitude, nothing but root 6 by root 6. Okay, now you can write it separately, like a cap is equal to, write separately. So 1 by root 6 into I cap plus 1 by root 6 into j cap plus 2 by root 6 into k cap. This is the required unit vector to the given vector. Simple. Okay, this is the given vector. Okay, simply you can divide the given vector with its magnitude. That is the unit vector. Okay, and we have seen that magnitude nothing but sum of the squares of the coefficient of I, j, k. Okay, here the first question, what is the, compute the magnitude of the following vector here. Magnitude of given vector can be represented like this. This is equal to square root of I coefficient square, j coefficient square. I coefficient is 1, j coefficient plus k coefficient, that is 1 square. That is nothing but root 3. So the magnitude of first one is magnitude of A is equal to root 3. And second one is magnitude of B vector is equal to square root of 2 square plus, yeah, minus 7 the whole square plus minus 3 the whole square. Nothing but what? So negative become positive, 4 plus 49 plus 9. This is equal to what, students? Square root of 4 plus 49, 53, 62. Is it right? Now coming to the third one, like magnitude of vector C is equal same 1 by root 3 the whole square plus 1 by root 3 the whole square plus minus 1 by root 3 the whole square, nothing but this is clearly equal to root of 1 by 3 plus 1 by 3 plus 1 by 3, that is 3 by 3, that is 1. So the magnitude of vector C is 1. So now already we have seen for one section B1, I think the second question, write two different vectors having the same magnitude, same magnitude. Okay, we can give n number of example, two different vectors having same magnitude, right? I'm going to take two different vectors here. Like first vector A, I'm taking as like I plus 2j plus 3k. Is it okay? And vector B, I'm taking as minus 2i plus j plus 3k. Okay, and C vector is, yes, anyone? Minus I minus 2j plus 3k. And like that we can write like different vectors, vector D, anyone, like 3i minus 2j plus k. But see here, you should be repeat 1, 2, 3. But I'm interchanging the coefficient of I, j, k, and I'm changing the sign alone. But instead of that, you should not take any other value like 1, 2, 3. I'm taking here also minus 1, 2, 3. 1, 2, 3 only repeating, different sign. Okay, whatever the vector, you can take magnitude, like B vector magnitude and vector C vector magnitude and D vector magnitude. In all the cases, you are going to get only one value, that is 1 square plus 2 square plus 3 square. This is equal to 1 plus 4 plus 9, that is equal to root 14. Okay, so these all are different vectors. All are different vectors, but magnitude is same. Like they are asking only two different vectors having same magnitude, but I have taken more than two. Like you can also easily take that. And next, write two different vectors having same direction. Same direction. Nothing but you should not change the signs. You should not change the signs. Okay, like if I take any vector, the third one is like when I take the vector A is like I plus j plus k. I'm taking all are positive. Another vector, B vector in the same direction means all should be positive. All should be positive. So you can multiply with a non-zero scalar. Multiply like I'm taking 2i plus 2j plus 2k. Yes or no? Yes, and C vector I'm taking as minus 3i minus 3j minus 3k. Yes. So these are all having same direction. Same direction means you should not take a negative value. If you take negative value, like you can take 3i, 3j, 3k. Okay. And these are the two example for the same direction. I'm going to take another example. C vector I'm taking as like 3i minus 2j plus 3k. And D vector, any one, what about the same direction? Yes, like multiply with 2 or multiply with 3, or I want to dividing with 3 here. Dividing with 3 means I minus 2 by 3j plus k. These two are same direction, as well as I have given example for even these two are parallel vectors, parallel vector. Okay, A and B are the parallel vector, because parallel vector concept is what? The vectors like this is vector A and this is vector B, okay, and this is vector C. Direction is different, but here A and B and C vector, I'm taking at last one is C vector. So direction is not important, but just you have to see that whether they are parallel or not. Yes, A, B, C are, these three are parallel to each other. All three are parallel, but how can you represent mathematically this parallel vector. Very simple. A vector A is equal to, we can write lambda times of B vector. You can multiply with some non-zero scalar here. Lambda should not be equal to 0. Non-zero scalar. Lambda is not a vector. Lambda is a scalar. So here we can easily say that A comma B are parallel. And if you may write like a vector A is equal to some K times of C vector. Yes, we can write C vector is equal to some you can take any lambda 1 times of A vector or B vector, and also we can easily write the linear combination. So see students, any two parallel vector we can represent like this. Here lambda is belongs to real number. Lambda may be positive, may be negative, may be decimal. Okay, it should be belongs to R. Fine. Okay, fine. Since we know that addition of two vectors, difference between two vector, and multiplication, let us see later. Addition and subtraction.
Sir, you can start it left.
When they have given two different points, how can you find the vector? I'm going to explain you triangular law, parallelogram law. Okay, and whether it is satisfy commutative property or not. Yes, vectors always satisfy commutative property. Commutative property and additive basic properties. A vector plus B vector always equal to B vector plus A vector. This is called a commutative property. Second one is A vector plus B plus C vectors can be written as A plus B plus C vector. Yeah, it will be satisfy associate property. This is called a commutative. Okay, this is called associative property, and it should be satisfy identity property, like 0 vector plus any vector should be equal to the vector A plus 0 vector should be equal to A vector. Nothing but here 0 vector is called additive identity. So the vector should not be like, if you apply the property, if you're adding additive, if you're adding any vector to the given vector cannot be changed, then that is called the identity vector. What is a multiplicative identity vector? Like, is there any multiplicative identity vector? No, because you know one is a multiplicative identity in algebra. You can take x as any number, 1 into x, so x into 1 is equal to x. So 1 is identity, x plus 0 plus 0 plus x plus is equal to x. Okay, additive identity or multiplication identity. But whereas in vectors means you may take I cap, j cap, k cap. That is unit vector, but there doesn't exist any multiplicative identity of the vector concept. These and all, okay, simple properties. And coming to the questions I told you that very easy. Like coming to your when
Sir, can you show the slide? Okay, sir.
Commutative. Sum of two vectors always a vector. Difference between any two vector always a vector. Sometimes 0 also can be written as 0 vector. Yeah, see here question number 4 is find the value of x and y when these two are vector. When equating means, see, when we can say the two vectors are equal, their corresponding components must be same. The corresponding component must be same. If I take any two vectors, like vector A is equal to, I'm taking 2i minus 3j plus 4k. and vector b is equal to, I'm taking like 4k plus 2i minus 3j. What about this a and b vector, students? A and B vector, is here vector A is equal to vector B or not? Nothing but only you have to remember that when we want to say two vectors are equal, magnitude must be same and corresponding the scalar component must be same. Nothing but I coefficient, J coefficient, K coefficient. So what is the I coefficient here? 2. What is the I coefficient? 2. Right. J coefficient is minus 3. Here J coefficient minus 3. K coefficient is 4. Here K coefficient is 4. So here A must be equal to B. In the same way here, I coefficient is 2 is equal to X. So X is equal to 2. The Y is equal to 3. That's it. And coming to question number 5, and find the scalar and vector components. Scalar and vector components with initial point 2 comma 1 and terminal point is minus 5 comma 7. Okay, this is very easy question. Like initial point is 2 comma 1, 2 comma minus 5 comma 7. So I'm going to take a vector whose initial point is 2 comma 1 and terminal point is minus 5 comma 7. So now to find the scalar component and the vector component, first point I'm comparing with x1, y1, this is x2 comma y2. Okay, after that, scalar components. So you have to find the vector AB. Let us take this is point A, this another point is B. You may find vector. After finding the vector, you may take scalar components, or else we can take directly also. Scalar components. Scalar components always is equal to R. Scalar components are x2 minus x1 comma y2 minus y1. I already given this x2 minus x1 minus 5 minus 2, 7 minus 1. Minus 5 minus 2 is minus 7 comma 6. So minus 7 comma 6 are scalar components. Scalar components. To find the vector component, first we have to find vector AB. Vector AB. Vector AB means you should write OB vector minus OA vector. This is nothing but what student very carefully have to do. I'm going to take the initial point is origin 0 comma 0. So like when I join this is a vector OA, this is vector OB. Okay, like position vector of the point A is OA. It can be written as position vector of the point B is OB. Every vector having, like every vector can be written as like OA, OB, OC, like that. Okay, every vector having an initial point as well as terminal point. But here the question is, we want to find AB vector. AB vector, according to the triangular law, actually it can be written as like a terminal minus initial. Like OB minus OA, this is one of the formula, very important formula. OB vector means minus 5 minus 7 is there. You should write minus 5i plus 7j. Okay, that is OB minus OA, 2i plus j. This is a method one to find the vector equation, vector AB. Vector AB is equal to minus 5 minus 7i plus 6j. Simple. Already scalar components we got. Scalar components into unit vectors. Another one formula directly when they have given two different points. Vector AB is given by AB vector is equal to x2 minus x1 into I cap plus y2 minus y1 into j cap. Already we found x2 minus x1 is minus 7. Y2 minus y1 is 6. So finally the answer is minus 7 I cap plus 6 j cap. That's all. Simple form. Either you can do in this way, AB vector is equal to OB minus OA vector, or else we can, with help of the point, like we can write AB vector is equal to x2 minus x1 into I cap plus y2 minus y1 into j cap. You can do any one of the way. Fine. Here we got AB vector, vector AB. Then what are the vector components? They are asking vector components also. Vector components is equal to minus 7i comma 6j. You can write the vector separately. Vector separately. For example, take any vector. For example, here this vector is there. A is equal to I plus j plus 2k. What are the scalar components here? 1, 1, 2. What are the vector component? I separately, j separately, 2k. I comma j comma 2k. Like that we can write. So the scalar and vector components are clearly minus 7 comma 6 and minus 7i comma 6j respectively. Okay, and yeah, question number 6 already. Find the sum a plus b plus C, very simple. So I minus 2j plus I and minus 2j plus 4j minus 6j and k plus 5k minus 7k. Like that, it is very easy to find the sum of the given vector. Okay, question number 8. Find the unit vector in the direction of PQ. Okay, they have given P and Q points. With help of P and Q, we can first find PQ vector. After that, PQ unit vector is equal to PQ vector by its magnitude. That's all. Okay, students. We'll continue the class after lunch break.